All right, let's look at this following system of two linear equations. All right, so the question is, how many solutions does this system of equations have? All right, so there are three possibilities since we're dealing with two lines. All right, if you have two parallel lines, distinct lines, and there's no intersection, so which means that there's no solution. If you have two distinct non-parallel lines, then you can see that two lines can only intersect at one point. So there's going to be a one solution. Only the last case would be if you have identical lines. So one line is right on top of the other line, then you would have infinitely many intersection points, which means that you have infinitely many solutions. All right, so we already know that there cannot be exactly two solutions, so we can immediately eliminate this case. All right. So it's going to be one of these three possibilities. All right, so since I like the slope-intercept form, so I'm going to rewrite this, both guys, write it in a slope-intercept form, which is the, the most popular one, right? Y is equal to mx plus b form, right? All right, so all we have to do with the first one is I'm going to just shove this guy over to the other side. So we can just subtract 2/3 x from both sides. All right, so you end up with y is equal to negative 2/3 x, and the 4 is still there on the right hand side. All right, so you can see that this is a straight line with the slope negative 2/3 and the y-intercept is 4. All right, so the second one is a little bit tricky. So let's try to solve this equation for y. All right, so first I'm going to move this negative y over to the left-hand side. All right, so you're going to do, actually, why don't I do this? This is probably easier. So why don't we just switch sides? So I'm going to, switch left-hand side and the right-hand side. Just switch them, right? We can do that, right? So we have 12 minus 3y is equal to 2x, right? That's probably easier, right? Then first step, I'm going to move the constant term over to the right-hand side. All right, I'm going to subtract 12. Then we get negative 3y is equal to, all right, so we have a 2x, and then we have to subtract 12. Right, we have that. All right, then last step, we just need to get rid of this negative 3. So I'm going to divide through by negative 3. So we get negative 3y by negative 3 is y. So we have that, which is exactly what we wanted. All right, 2x by negative 3 is negative 2/3 x. All right, negative 12 by divided by negative 3 would be positive 4. Right, and as you can see that you get exactly the same equation here. So this is the first equation, and here's the second equation. They turn out to be identical, right? So you have actually two of the same lines. So therefore, there are infinitely many intersection points, which means that we have infinitely many solutions. All right, that's it. I hope that this was clear.